Conditional probabilities, if you recall, deal with the word if or the word given. They give you a different look at probability. Instead of looking at a whole sample, we're going to break it up. So instead of looking at all students in a classroom, we would say, if the student was female, what's the probability of being suspended? Those kind of things. So we give specific conditions to the probability problem, which is why it's called a conditional. So we're looking at this statement. According to a 2006 European study, the risk of developing lung cancer for a man who never smoked is 0.2%, and the risk for a current male smoker is 15.9%, which is almost 80 times higher in terms of relative change. So number one, first off, restate the given probabilities as conditionals. So if we start with the first one, I'm going to use this thing. It's a man who's never smoked. So if you are a man who never smoked, then you could say probability of lung cancer is 0.2%. But the whole concept of if you never smoked, right? That's the process. The other one, if you are a man who smokes currently, so who smokes, probability of lung cancer is 15.9%. Again, conditional probability because of the if. We're separating the group. We're not looking at all men. We're separating them between those who smoke, those who don't smoke. And when you do that, you create conditional probabilities. Okay, let's do some problems with this. Oh, no, I lied. We're going to do one more question with this. I'm not prepared here. How did the researchers find each probability? Okay, so first we'll talk about the men who never smoked. So you've got to go with, and we're talking about lung cancer. So I'm going to get all men who never smoked, okay? And I'm going to put them in a room. So there's my all men who never smoked, and that's going to be my denominator. So all of these men. In the top, it's the number who have lung cancer, but only pulled from the men who never smoked, right? Because those are the guys I'm dealing with. And that's how they got the 0.2%. Now they put all smokers in a room. Okay? So all of these smokers would be the denominator, and in the top, it's the number with lung cancer. And that's how they got the 15.9%. Now, my question for you is, and I'm sure you might have been talking about this, we talk about a man who has never smoked and a current male smoker. Well, what about those people who have smoked at some point in time but are not smoking now? Where do they go? I don't know if those are even in here. But that's neither here nor there. That's just a question I have randomly. But that's how they figured out their probabilities. Okay, now let's do an eye color problem. We've got males and females. We've got blue, brown, and green. All right, so the first one. Find the probability of choosing a student with green eyes if a male. So first we are going just males. And because it's just males, my total is 392. And now I say, okay, green eyes. Here's green eyes right here. So my numerator is 31. So 31 out of 392 is 0.079, which is approximately 7.9%. So if you have a male in a room, you've got a 7.9% chance of finding one with green eyes, if it's just males. Number two, find the probability of choosing a female with blue eyes. Is there an implied condition here? Now, I don't see the word if, I don't see the word given, and that doesn't necessarily mean that you have a conditional. But when I read this, and if you see it differently, please send me a message. But when I read this, find the probability of choosing a female with blue eyes. To me, this looks like an and statement. I want a female with blue eyes. I want a female and blue eyes. So a female with blue eyes is here. That's an intersection problem out of the total. So that's how I read it. I read it as I have a 12.7% chance of, and that's out of everybody. Now, I'm not sure if this was meant to be as a conditional where if it's a female and they have blue eyes, I'm not sure. So I read it as find the probability of choosing a female with blue eyes, which is a female and blue eyes out of the total. If you read it differently, please do let me know, but that's how I read it, as an and problem. Now, And number 3, given that a student has blue eyes. Okay, now this one says has blue eyes. We know that. The key word there is given. My denominator is going to be 318. What is the probability that they are female? 105. So 105 over 318 is 0.33, which is 33%. So if you have all the blue-eyed people in a room, you got a 33% chance of finding a female. And how is this different than number 2? Well, in number 2, we talked about the female and blue eyes out of everybody. And in this one, we just talked about if they have blue eyes, whether or not they're a female. Now, yeah, I'm just going to go with that. Number 4, I added this one. If a student has brown eyes, what is the probability they are male? So if they have brown eyes, probability of male. So that'd be 148 out of 409, which is 0.36 or 36%. So just remember, whatever follows the word if or the word given, that's what's going to give you your total or give you your denominator. So if brown eyes, there's my total, that's my denominator. And that's kind of the key to conditional probabilities.